Hello, proposition 7 done over again, okay? So it hopefully be a little more clear. I'm going to do this in 2 or 3 parts just to make sure we have it. Look, there's our given line, okay? Here's the enunciation, the truth. It was true for your grandfather, true for your father, it'll be true for your grandkids. Given a line and 2 straight lines constructed from the extremities meeting at a point, if you do that, you cannot construct 2 other lines on that same straight line, on the same side, from those same extremities, 2 lines meeting at another point, such that these 2 lines will be equal and these 2 lines will be equal. If you have 2 other lines constructed, there can't be that kind of equality in those lines. Oh, Mr. Smarty Pants says maybe there can. Okay, that's how we're going to prove this prop of reductio ad absurdum. Okay, so let's get our first 2 lines meeting at a point. Let's construct a line and another line from the other extreme meeting it. Okay, so here we have 2 lines coming up. Great. I tell you that you cannot construct 2 other lines meeting at another point such that that new line will be equal to this line and the other new line will be equal to this line. Mr. Smarty Pants says you can. Okay, that's cool. I mean, it's not a crazy thing to say. Let's say you can. We're going to grant Mr. Smarty Pants' premise, his position, and we're going to reduce it to a real absurdity that you can have equality and inequality. Not even Mr. Smarty Pants wants to say that. So let's have some fun. Okay, well, let's construct another line. And then another line from the other extremity meeting that new line. Okay, cool. Now, it cannot be the case that these 2 are equal and these 2 equal at the same time. That's impossible. Let's show how that's impossible. I'm going to do a little trick here. I'm going to connect these 2 points. We know we can do that, but you might say, why are you going to do that? Because I want to use this triangle thing. I want to create some triangles to get us to our reductio ad absurdum, okay? Now, I'm going to make it dotted like this with blue and dotted like this with red, just to manifest to my loving students that the base of this triangle is the base of this triangle. They share the same base. But for now, just focus on this triangle, the blue one, with the 2 sides being equal. You see that? That's an isosceles triangle. Got that? A triangle, 2 sides being equal, isosceles. What do we know from our bag of knowledge about isosceles triangles? That in isosceles triangles, the angles at the base are equal. So we know, definitely, it must be the case that this angle and this angle are equal. I know it looks weird, but again, we're doing a reductio ad absurdum, and so the image is always going to, but the intellect says, okay, I can do that. So these 2 are necessarily equal according to Mr. Smarty Pants' premise. Great. Now, if this is equal to this, look at this whole compared to this part. This part right here. This whole is greater than the part. Great. Well, if this is equal to this and this is greater than this is also greater than this. You see that? This blue angle is greater than this green angle. Oh. And this big old angle, then, which is the whole of this part, so this is greater than this, but this is greater than this. So this angle must be much greater than this angle. This big old red angle must be much greater than this big old red, little old red angle. But look at here now. Here we have an isosceles triangle. And we know from our bag of knowledge that in isosceles triangles, the angles at the base are equal. So this being an angle at the base, and this being the other angle at the base, this is necessarily equal to this. But from our previous thought of logic, it was necessarily the case that this is much greater than this, that is to say, unequal. So now you have a case where this is equal to this and unequal to this at the same time in the same respect. Boom. A logical absurdity. So that position that Mr. Smarty Pants granted, that it can be the case that you can construct 2 sets of lines such that the other lines are equal respectively, it must be false. Because if you say that it's true, you come to an absurdity that we have equality and inequality at the same time in the same respect. That is to say then, if it's false that you can construct two lines from the extremities meeting at another point where you have the two lines equal respectively, if that's false, it must be true to say that you cannot do that. So if you have these two lines meeting here, you can have other two lines meeting there, but you're not going to have equality between the lines respectively. Quod erat demonstrandum. Thank you so much. Bye-bye.